Hello, welcome to Lab Report number 5. Let's start with the list of materials used in this lab. The first one is motion sensor, which is used to record and analyze the data. Next, we have the weights used to obtain different data. Then we have the art track, which was used to create a frictionless environment. Next, we have the metal plates used to create a slope. And finally, we have a yardstick used to measure and calculate the data values. Next, we continue with the procedures. For this experiment, we raised the before using air track up using metal plates to varying heights depending on the number of plates used, as well as playing weight different amounts in order to see the effects that having a slope and varying weights can have on the acceleration observed. Firstly, we raised the height of the track using the plates. For the first run, we did 1 centimeter of the base. Then we adjust the weight of the card and decide the ultimate length of the track that will be used as one of the side measurements to calculate the data. Once this was done, we ran the lab, go data, and run calculations. We repaired this with variables height and weight in order to draw the conclusion that will be later discussed in this presentation. Then we have the video that was taken as evidence of the experiment that we shows each material that was used and show how two graphs and their results were obtained, and this is show the three graphs we made with the specifications recurrently by each calculation. Next, we have the calculations and the graphs. And in this part of the presentation, we show the calculations performed during Lab 5. The main object of was determining the acceleration of the system using the experimental data that we collect, such as velocity and time, and it compared those results with the theoretical acceleration. The first one we worked with the mass one of 200 grams and weight of 1 of 6 centimeters. For this case, two measurements of velocity and time we recorded. This first velocity was approximately 0.05 meters per second with a time of 0.45 seconds. And the second velocity was about 0.37 meters per second with a time of 4.60 seconds. To calculate the accelerations, we use the formula based on the change in velocity divided the change in time. This means we subtract the initial velocity from the velocity and divide it by the difference between the final time and the initial time. After performing these calculations, we obtain an acceleration approximately on 0.081 meters per second squared. This value represents the experimental acceleration of this first measurement. Next, second calculation was performed using mass 2 of 300 grams, keeping a similar setup in the experiment. In this case, the initial velocity was approximately 0.02 meters per second with a time of 0.40 seconds, while the final velocity was around 30.37 meters per second with a time close to 4 seconds. By applying the same acceleration formula, again we obtain an experimental value of approximately 8.078 meter 87 meters per second squared. After that, the experimental allowed use shows between 200 grams or 300 grams, but this time using a second weight for the conditional the theoretical acceleration is about 0.064 meters per second square, which serve a reference to compare with the experimental results. And in the third case, we use a mass of 300 grams with a height of approximately 0.66 centimeters. The record measure with an initial velocity of 0.07 meters per second with a time of 0.77 seconds and a final velocity of approximately 0.38 meters per second with a time of 5.60 seconds. Once again, we apply the formula of changing in velocity divided by change in the time to determine the accelerations of the system. Then these are the graphs generated from the experiment, and the calculations were based on the graph, and each graph was created using different weights and heights, and each calculation we based on data from each graph. Then next we have a little explain of how to an incline affects acceleration. As the angle of an inclined plane increases, the component of gravitational forces acting along the surface also increases. This causes the car to accelerate more rapidly down the track. The acceleration is determined by relationship accelerations, gravity is in theta, meaning independence only the angle of the incline, not the mass of the car. By adjusting the height of the track is using slabs, we directly change sin data, allowing is the observer how even small changes in tilt produce measurable differences in acceleration. People are experiencing this every day, especially around UTEP when they go up. And then we have a little explanation of why mass doesn't matter. One of the key ideas demonstrated in this lab is that the acceleration of an object on a friction reduced incline is depending of its mass because both gravitational forces and inertial scale proportionally with mass. The mass cancel out the equations of motion. As a result, adding weights to car doesn't no significant change its acceleration. This mirror Galileo's original instinct. Objects accelerate at the same rate on an incline regardless of how heavy they are as long as friction is minimized. Uh, to finish this lab report, we have the conclusion. In this experiment, we investigate how changing the angle of inclined planes affect the acceleration of a car by raising the track with slabs and concluding and calculating the same data value from the geometry of the setup. We determine for theoretical acceleration for each inclining or measure acceleration increase it constantly as the little become strip matching the prediction data acceleration. Gravity seen data. Additionally, changing the mass of the car produced little to no effect on acceleration, reinforcing the principle that mass does not influence gravitational accelerate on a low friction incline. The comparison between theoretical and experimental values show a reasonable agreement, with a net difference likely due friction, alignment imperfections, on timing variations. Overall, the lab demonstrates the relationship between angle and acceleration and provide clear evidence of the fundamental physics governing motion on an incline. And finally, the credits. Thank you for watching.